Okay, now we're going to talk about exponential decay. Exponential growth, we noticed it would, let's see, how do we do this? It would start going slowly this way, and it would get faster and faster and faster and faster, go really fast, right? Exponential decay is the same thing, only it starts very, very slowly, slowly, it starts to decay really fast. Okay, that happens with populations of fish in streams. It happens with radioactivity, radioactive ingredients, radioactivity within you know, a substance or so forth. The decay of radioactivity, actually that's not going to be necessarily a fast one, so maybe that's not the best example. But anyways, exponential decay. Alright, so here we go. Notice the formula looks almost exactly like exponential growth. The only thing is, the only difference is there's a minus sign. And it makes sense because if growth would be 1 plus the increase, plus the percentage increase, decay would be 1 minus the percent increase. So it's actually, notice, anything less than 1 is going to be like a fraction, a decimal. So when you multiply a fraction times something, you actually make that something smaller. And so it keeps getting smaller and smaller and smaller. So in this example, it says the fish population in a local stream is decreasing at a rate of 3% per year. Again, 3% per year. If I was going to write that as a decimal, I would move the decimal over 2 places, 0.03. Okay, fish population local stream is decreasing at a rate of 3% per year. The original population in 2005 was 48,000. 48,000 fish, right? Write an exponential decay function. So this is an exponential decay function without the information in it. We're going to take that function, we're going to put information in it. All right? Write an exponential decay function to model this situation, then find the population today. All right, so as long as you know your formula, it's a piece of cake. So we're going to go y is equal to A again is my original amount, r is my rate of decay, not my rate of growth, my rate of decay, always written as a decimal, and t is my time in years. So my A is my original amount, which is 48,000. 48,000, yes. Times, I do 1 minus the rate. Well, let's think about that for a second. 1 minus 0.03 raised to the t. Now, we've got today's 2012, that was 2005, 5 from 12 is 7, so we're going to say raised to the 7th power, okay? Now this is unfortunate. We've got to do something here. We can't just leave it like that because I can't do 1 minus 0.03 raised to the 7th. I've got to combine what's inside the parentheses. That's what PEMDAS says I have to do. So if I have 1.00, I take 0.03 away from it, I'm going to get 0.97. So you can use it on a calculator. Okay, not a good time. Hang on. Okay, it's for you guys. Just be right. Hey, Nate. Hey, Nate. Yes. Yeah, they're supposed to check on my website. That's always the case, so just tell them to check my website, okay? Okay, thank you. Bye. All right, sorry for that. Forgot to write on the board the homework was. Okay, so y is equal to 48,000 times parentheses 1 minus 0.03 raised to the 7th power. Now I got to get that simplified, so we just figured out that was y is equal to 48,000 times 0.97 parentheses raised to the 7th power. Now I find my calculator. Okay, I'm going to raise my find my calculator. I'm going to do 0.97 raised to the 7th. So 0.97 raised to the 7th power, that equals 0.81 approximately. So it's 48,000 times 0.81. All right, I'm going to multiply that times 48,000, and it gives me 38,783. So y is equal to 38,783. So after 7 years, my population went from 48,000, just under 10,000 less, to 38,000. And that is my answer. It's that is in fish, okay? So again, you would write the answer in an actual sentence. That's it, because I think I have to go. Okay, see you, bye.